All right, hello, it's me, Mr. Burkhardt. Just going to give you some notes here for your quiz this week. We're going to talk about energy, different kinds of energy we've talked about before. Let's talk about this first equation. The K stands for kinetic energy. Kinetic energy is the energy the thing has when it's moving. And so in order to have kinetic energy, you have to have mass. M is for mass, which we should know what mass is. It's the amount of stuff you have in kilograms. Like how much of it is there in kilograms? It's what mass it is. And V is for this formula is for velocity. Sometimes I say speed, but and for this formula, it doesn't really matter which word I use because that the value is squared, and that means it'll always be positive, right? Whenever you square any number, the square of any number is always positive. And so what does squaring mean? To square a number means to multiply it by itself. So 2 squared would be 2 times 2, and 3 squared will be 3 times 3. And you can also do that with variable numbers. So we use letters to represent numbers that can vary. So an object could really have about any speed, right? It doesn't have to just have one speed. And that's why we use v for a variable for velocity. And so that's just that letter just represents whatever the speed is. And whatever the speed is, we're going to square it or multiply it by itself. So if the speed was 4 meters per second, it would be 4 times 4. All right, so what I want to do is talk about what will happen. So if you have two cars and one car has a mass of 5 and another car has a mass of 10, which one will have the most kinetic energy if they have the same velocity? Let's see, they're both going at the same speed. Which one's kinetic energy will be the biggest? And how much bigger will it be? And so the answer is, if the mass is twice as big, the bigger one will have more kinetic energy, and its kinetic energy will be twice. So if the mass is double, the kinetic energy is double. All right, now let's take a look at two cars. Let's say they both have a mass of 7. Both of their masses are 7, but this one's speed is 5. Let's just use a different number, 4. And this one's speed is 8. So let's go ahead and put some units next to them so that we don't get mixed up. Right, it's meters per second. I'm just going to write kilograms here in between these two. Oof, that's pretty ugly. Right, they're both the same mass, so the mass doesn't change. Right, we can just draw that. We can make a little arrow like this over it to show the mass isn't going to change, but one of them's got more velocity. So which one will have more kinetic energy? And how much bigger will it be? So you should recognize that the faster one has more kinetic energy because 8 squared is bigger than 4 squared. And how much bigger? So that answer is, yeah, the fast one has got more energy. So that's probably not that hard to figure out. But how much more is it? Well, how much bigger? So 4 squared is 16, and 8 squared is 64. How much bigger is 64 than 16? Is it twice? Is it double? If you said double, then it's not true because 32 would be double 16, right? But the energy is going to be 4 times bigger. 16 times 4 is 64. So if you double the speed, the energy will increase by 4 times. It'll be 4 times more energy. This is why speeding in your car is such a terrible idea. Because if you increase your speed, you say, well, I'm only going 10 or 20 miles over the speed limit. Yeah, but you're doubling the kinetic energy of that car by a square factor. And you have so much more kinetic energy. And then when you crash, well, work is going to be done on that car, and it's not going to be pretty. All right, so that's what I wanted to talk to you about here with this kinetic energy piece. This other formula down here is potential energy. I forgot to write potential energy. And that's equal to mgh. Mass, same as it was for kinetic energy. Gravity is little g, which is 9.8. Little g is 9.8 for this planet. You can change that if you're on a different planet. Like on the moon, it's 1.6. On Mars, it's 3.2, I think. I have to look it up. And Jupiter is like 4 times, almost 4 times more, almost 30. So almost 3 times more. And h is how high we are from some point. So we're going to just pick a spot to be 0, and then if we have an object above that spot, H, right, then, because it doesn't really matter, the reason that this can be we can pick any place to be 0, a lot of times we just pick the ground, that's easy. But it's really, we're talking about a change in energy. So if where this energy all comes from is from doing work. If we push on a box, we speed it up. And then we've done work on the box by pushing on it, and that gave it kinetic energy. If we lift a box in the air, we do work on it, and when we do work on that box, that gives it gravitational potential energy. So again, let's say we have 2 boxes. One is 5 kilograms. We're going to talk about the mass, and the other one is 10 kilograms. Which one, if they're both lifted up to the same H, which one has the most potential energy, and how much bigger is it? So you probably realize that the big one has more energy, because if M is 10, if that's bigger than when M is 5, if H and G are the same, right, because it's the same planet, it's the same height. But how much bigger is it? Well, that would be double. We're doubling the mass. In either equation, when you double the mass, you double the energy. If you have the mass, you have the energy, and it's proportional. It's just a direct proportion. But now let's change that height. So let's say they're both going to be 7 kilograms. So we have a 7 kilogram here, and then I'm going to double the height. Whoop, whoop. Let's just say that that's double the height, and I have 7 kilograms up here, right? So this is 2H. I don't think I actually did it right, but let's pretend like I did. All right, so how much more energy, which one has the most energy, and how much more is it? And you should have guessed that the higher one is more energy, and it's also double. So basically, we don't have a square in this formula. So if we double the mass, we double the energy. If we double the height, we double the energy. We don't really change G unless we go to another planet. Right? So G isn't really going to change unless we specifically say, hey, let's pretend like we're on Mars or some other planet. You can just count on G being 9.8. And you are also, if you want to, you could call it 10. And I wouldn't get mad, because, it rounds off to 10. All right, so the other part of this lecture is time's up. Dang it, these guys. All right, so the other thing I want to talk about is, let's say we have a bobber here. So we've been playing with this gizmo for a couple of weeks now. Let's say that its mass is 1, and let's change the length. Let's say the length is 0.5. There it is. And so if the length is 0.5, and we're going to go, you can see it has a certain speed when it crosses the y-axis. Is that going to be faster, slower, or the same if we change the length to 1? So let's grab this and say, where is it going to be? Is it going to be faster now, or is it going to be the same, or is it going to be slower? All right, well, you know what? I can't really tell. So I'm kind of looking at my velocity, my graph here as it spins and spins and spins. And maybe this is a way I can tell. I didn't really think that through, I guess. I think it's the same. Hard to be sure without numbers. Oh, you know what? That looks, honestly, that was definitely slower. Before I was seeing velocities of 1 point something, and now I'm not seeing any velocities that are 1 point something. I'll show you. Let's go back to making this 1. So just make it 2. Yeah, see, now it's definitely faster. So changing the length of the string makes it faster. More string, faster. All right, so let's stop that. And now we're going to just set the string length. Let's just say that it's 1. Let's change the mass. How will changing the mass? All right, so here's 1. So I'm seeing about 1.3. As it flickers through, I'm seeing 1.3. All right, does it change? Basically, I can also look at this chart here. Does it change the kinetic energy to change? Well, that's not going to tell me the speed. When is it going fastest? Okay, so we have to go back over here. And let's go ahead and change the speed. And no, not the speed. Let's change the mass, sorry, to less. Let's make it a lot less. And you know, as I look at this, it doesn't really look like it's going any slower. It's actually got the same speed. So changing the mass doesn't change the speed. Changing the length changes the speed. And here we have, let's change the gravity. Let's say the gravity is 50. Will it go faster or slower? Oh yeah, that's clearly faster, right? Woo! Increasing the gravity definitely makes it go faster. All right then. So for the other part of this quiz, we need to make sure that you do the other gizmo, which is being released on Thursday. And let me just turn it on for a second. It's called Sled Wars. And what you're going to do is you should be able to predict which. So if you have an abominable snowman here, you should be able to predict how changing the mass of the snowman will affect the number of snowmen that get slaughtered. So we can, where's the goat? There it is, booms, right? So when we have the snowman set up like that, boom, 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 you killed 3. So if I, let's just go ahead and make it 5 snowmen. So this is a 100 kilogram abominable snowman at the top, you can kill 3. How about a 200 kilogram snowman? How many will he kill? More, less, same? Definitely more, right? And so that's what you need to play with this and be able to answer questions about the snowman and the sled, hitting the snowman, or we can actually make it 2 sleds, and we can ask which one is going to win the contest when they hit each other, or will they have it? Which one will push the other one backward, right? So make sure you can answer questions like that. And I think this video has gone on long enough. So let me go figure out how to stop it.